Let's look at some examples of multiplying rational expressions. You'll notice we have two examples here, both with polynomials in the numerator and denominator, and in each case, a fraction times a fraction. What we want to do to multiply these is that we want to be able to simplify before we multiply straight across. To do that, to simplify fractions, we need to have them factored. So we have a numerator of 2x plus 4 in our first fraction. There's a 2 in common, so take the 2 out, and we're going to be left with x plus 2. In the denominator, x plus 1 has nothing in common, so we'll leave it as x plus 1. Now, I like to put parentheses around that to let myself know that I tried factoring and it didn't factor. In the second fraction, again, we want to factor both the top and the bottom. The numerator is a trinomial, so we're going to factor to two binomials. So we're going to have x times x for x squared. The only way to factor a 2 is to 2 and 1, and since I want a positive 3, I'll use a plus 2 and a plus 1. In the denominator, I have 4x plus 2, which has a 2 in common. So if I take the 2 out, I'll have 2x plus 1. So now we have both fractions, numerators and denominators, factored. Now we want to look for common factors within the numerator and within the denominator. Remember, the idea is that these numerators will eventually be all together, and so will the denominators. So we don't have to just stick within a single fraction. We can cross-cancel here. So the 2's in the numerator and this 2 in the denominator are the same, so we can cancel them. They're both common factors. Another thing we can cancel is this x plus 1 that's in the first denominator and in the second numerator. It's tempting to try to cancel the x plus 2's that are in the numerator, right here and here, but they're both in the numerator. You can only cancel numerator to denominator. You cannot cancel if they're in the same portion of the fraction. So at this point, we've canceled whatever is common in the numerator and denominator, so we're going to rewrite what's left. In the numerator, I have x plus 2 and another x plus 2, and in the denominator, I have 2x plus 1. Everything else canceled to 1, so this is what's left. Now you might think we would multiply that out, but actually we tend to leave things factored in answers when we multiply or add or subtract or multiply rational expressions. The reason for that is that if we have to do something else later on to that answer, it's sometimes better to have it in factored form. So we're going to leave this factored. But one thing we will do is x plus 2 times x plus 2 can more easily be written as x plus 2 quantity squared. And since the 2x plus 1 in the denominator is not really multiplying anything anymore, we don't need the parentheses around it. So that's our final simplified answer. Let's try another one. In the next problem, we have, again, a fraction times a fraction. To work with this, I'm going to factor both the numerator and denominator. To factor the numerator, I have a difference of squares, so I'm going to factor that into the square roots with one sign that's positive, one that's negative. In my denominator, 5a minus 2, I have nothing in common, so I'll just put it in parentheses to remind myself I tried to factor it, but it won't factor. My second numerator is written a little differently. It is not in descending order. Do you see how the 15a comes after the 6? Remember, the hint when you don't have it in descending order is that there may be a negative factor involved. So I'm going to rewrite that as negative 15a plus 6. And in my next line, I'm going to factor out a negative factor. The denominator I can factor. It's in descending order. I'll factor that to a product of binomials, a, and then minus 6. If I factor that, I want one of each sign, a positive and a negative. If I want a positive 5, I want a plus 6 and a minus 1. Continuing down, we're going to factor this second numerator. It has a negative at the beginning, so we want to factor a negative, but we also want to factor anything it has that's common. Before I do that, though, and continue down, we can, to save ourselves some writing time, cancel out anything we see that's currently common. In fact, in the numerator, I have an x minus 1 in the first numerator, and I have an x minus 1 in that second denominator. I can cancel those as I move down. So now I have an a plus 1 in the top of the first fraction, a 5a minus 2 in the bottom of the first fraction, and that's multiplied by, now I have a negative in front, so I'm going to factor in negative, and then I have a 3 in common with the 15 and the 6, so I'm going to take out the negative 3. Negative 15a divided by negative 3 is 5a. Positive 6 divided by negative 3 is minus 2, and that's over a plus 6. And now you see it was a good thing I took the negative 3 out because I do have one more common factor. The 5a minus 2 in the numerator and denominator can be canceled. So what I'm left with in the top is this a plus 1 times the negative 3. It's tradition in mathematics to put the monomial in front. So we'll have negative 3 times, in parentheses, a plus 1. And in the denominator, we have an a plus 6 left. I don't need the parentheses in the denominator because it's the only thing left there. So that would be our simplified result. Now, one last note here. To show this work on these problems, I didn't really have room, because I wanted to show 2 on the page, to go across as for my first statement. So normally, you've seen me do this in the past. I went across and then down with my chain of equality. Another alternate way of showing the chain of equality is to just start right below the initial expression and show your equals as you go down, so that the initial statement is equal to what is directly all the way down below it. That's another common way that people will show a chain of equality. Here are 2 more examples of multiplying rational expressions. I recommend you try these on your own, so pause the video. Once you've tried them, unpause, and you can see me work through the problem. So in our first example, w squared minus 9w is over w squared minus 9, and that's multiplied by w squared minus 3w over w squared minus 7w minus 18. What we want to do first in this multiplication process is try to simplify if we can. So we're going to rewrite these fractions in factored form. In the first fraction, it's tempted to think of w squared minus 9w as a difference of squares, but notice the w is common. Always take something common out first. And when we do that, we see that we end up with w times w minus 9. It is not a difference of squares. The denominator, however, is w squared minus 9. Both of those are squares. There's a difference. So now we factor it to w and times w, and 9 factors to 3 and negative 3. In our second fraction, we again have a w, or a common factor. Take out the w and we get left with w minus 3. And in my denominator, I have a trinomial. A trinomial is going to factor to a binomial times a binomial. w's, and then minus 18. We want a pair of factors that add up to negative 7. Because 18 is negative, I want 1 minus and 1 plus. And in particular, I want the 9 to be negative and the 2 to be positive to add up to negative 7. So there we have everything factored in both the numerators and denominators. Now let's cancel whatever is common. First off, I see a w minus 9 in both the numerator and the denominator. I also see a w minus 3 in both numerator and denominator. That's all I see that's common between the numerator and denominators. There is a w in common in the numerators, but remember, you can only cancel numerator to denominator, not numerator to numerator. So in the top, we're left with w times w, or w squared, and the bottom, we're left with w plus 3 times w plus 2. Again, there's no need to multiply that out. We generally leave our answer in factored form. In our second example, we have an expression that involves both x and y. Now, with this, we don't necessarily look for descending order per se, but we look to make sure that they're written the same way. So notice we start with an x in the first numerator, and we continue to start with an x in the denominator and in the second numerator and in the second denominator. So these are written in the same order, so we don't have to worry about order here. What we want to therefore do is concentrate on just factoring as normal. So in my first numerator, I have a trinomial, x squared plus xy minus 12y squared. I'm going to factor that to a product of binomials. X and x give me x squared. Y squared is going to come from having the y split up. And then I want to think about factors of negative 12 that add up to 1. Well, that would be positive 4 and minus 1. And I don't have to put the 1 there because 1y is the same thing as y. Oh, except I shouldn't use a 1. I should use a 4 and a negative 3. Sorry. brain freeze there. I need a 3 there. So let's double check that since I made the mistake. X times x is x squared. The outside would be negative 3xy, the inside positive 4xy, and that does add up to the middle, positive xy. And then it also multiplies 4y times negative 3y to negative 12y squared. All right, so always double check as you're going. I caught that mistake because I was looking at it as I checked it. X plus 6y in the denominator is not going to change or factor any further, so I'm going to put parentheses around it to remind myself of that. In the next numerator, because there's only 2 terms, start by looking for something common. There's a 3 there. When I take the 3 out, I get x plus 6y. Because the x and the y aren't squared, we're going to have to stop there. There's nothing else common. In the denominator, I can't take anything common or factor it further, so I'll just put parentheses around it to emphasize that I've tried. Next, let's look at what is common now that we factored everything. I see an x minus 3y in the numerator and in the denominator. I also see an x plus 6y in both the numerator and denominator. So those cancel, we're going to be left with 1. And then what's left in the numerator and denominator for my answer is going to be a 3 in the numerator, an x plus 4y also in the numerator. So I want to show they're still multiplied, so make sure you have the parentheses there. In the denominator, everything canceled, but remember, canceling means 1 is left, so technically my denominator is 1. But when we have a fraction with a denominator of 1, we usually just drop it off. So my final answer would typically be written as 3 times x plus 4y. Again, no need to multiply the 3 out, although I wouldn't mark you wrong if you did. We just generally leave our answers in factored form. So there's our 2 simplified answers on those problems.